This is Walk the Walk. In this lab, we are going to practice calculating speed by measuring the distance and time that a person travels. So we're going to need to do this lab outside or in a place where there's at least 20 meters for people to walk. We are going to be testing 4 different actions. We're going to be testing walking, walking backwards, speed walking, and skipping. So the first 3 actions are actions where at least one foot is always on the ground, and skipping is an action where both feet leave the ground. So what we're going to do for this one is we're going to set out the measuring tape and we're going to run 2 trials for each action. The first time the person performs that action, like if they're walking, they're going to walk for 10 seconds and we're going to measure the distance they travel in that 10 seconds. Then what they're going to do is they're going to turn around and they're going to walk for 20 meters and we're going to time how long it takes that person to do that action for 20 meters. So just for the sake of time, what I've done is I take this measuring tape and I line it up really far. I put about 30 meters out and I put a cone at 20 meters. So the first time they're going to start at that 0 mark. They're going to walk for 10 seconds and at 10 seconds that person that's timing is going to stop them and they're going to measure how far that person traveled. Now, just so they don't have to walk all the way back, because that cone is at 20 meters, they're just going to start at that cone at exactly that 20 meters, and then they're going to time how long it takes for them to walk back. And this is going to be repeated for walking backwards, speed walking, and skipping. Now, this might seem like a silly lab just because we're measuring distance, we're measuring time, and we're calculating, well, how fast did they travel by taking distance divided by time. But in this lab, what we're doing is we're practicing recording measurements. So in order to determine how much of a measurement we need to record, we need to look at both of our measuring instruments. So let's take a look at that measuring tape. So if we zoom into the measuring tape, we need to look at the resolution. Now, if you look, the resolution of a measuring instrument is the smallest interval that can be measured by that instrument. So if we look at that and there's little dash marks, we can tell, well, what's the resolution of this measuring tape? Now we also have to decide if it has an uncertainty digit. So an uncertainty digit means that I can estimate the next digit, and this only happens with analog instruments. So what that means is if I'm looking at that measuring tape, I could make an estimate to that next digit if I'm measuring something and it falls in between those lines. So that is something that we need to record in this lab. So this gets a little bit tricky. If we're measuring our resolution in meters, because we want our speed in meters per second, if you look at that, you can tell that in between each of those centimeters, it's divided up into 5. So the resolution of this measuring tape is 0.02 meters. And we can make an estimate to that next digit. So I say, well, instead of going 1 digit below, let's just say we can make an estimate to 0.01 meters. Because it does get a little iffy because it's not in a perfect interval of 10. So now let's take a look at that stopwatch. So you can use a stopwatch on your phone. Let's decide what the resolution of this stopwatch is. So you can see that mine goes down to the 1/100th of a second. That's the smallest interval that can be measured by this measuring instrument. That's the resolution. Now, this does not have an uncertainty digit because it is a digital instrument. There's nothing to look at to estimate to the next digit. So when I'm recording values, I have to record my values down to the 1/100th of a second. Even if it's a 0, I should record it because I can measure it. So now let's go outside and measure the speed of people performing these different actions of walking, backwards walking, speed walking, and skipping. We're going to measure the distance that they travel in 10 seconds, and then we're going to measure the time it takes for them to do those actions, returning 20 meters. Then we can find the average speed between those 2 trials. All right, let's go outside. So now that we've collected the data, I'll put up the data that I got when I did this lab. Now, one thing to note, when calculating the speed, we are taking the distance divided by the time. So we needed to record the resolution and the uncertainty digit if it had one, just like in that measuring tape. When we're dividing, we need to make sure our answer has the same number of significant figures as the least amount of significant figures in the problem. So if there's one measurement that has 4 significant figures and one that has 3 significant figures, my answer needs to have 3 significant figures because my answer can only be that accurate. I do not have the resolution to say any more spots beyond that significant figure is accurate. That is just mathematical. We can use this data to make a nice little bar graph that shows the difference in speeds between those actions. So one thing to note, when we were calculating speed, we were calculating the average speed. We were not calculating the instantaneous speed. And I know that I'm calculating the average speed because I'm measuring distance and time. For instantaneous speed, I would need something like a radar gun or speedometer that would tell me that speed at that instant in time. So now using this average speed that we calculated for all of these, we could do something like, I don't know, calculate how long it would take that person to walk a mile or skip a mile using this equation. We could also do another problem and say how far would that person travel in like an hour using this equation. So once again, this is Walk the Walk.